Hey guys, it's Alexander. Today we're doing our first part, our two-part series revolving around renting NFTs on Flow. What's up everyone? Before we get into the rest of the video, I just want to introduce a super new and exciting grant program in which we'll be giving out $500 to developers like you who use our Flow videos and contracts to create a new and exciting Flow website inspired by them. So you have a good idea on how to use our videos or contracts in your own new website, then make sure to put a proposal below and have the chance of receiving $500. All right, now we talked about the grant program, let's get into the rest of the video. Now this part of the video will be very similar to a lot of the previous videos we've created. We'll be going into sort of the setup for these NFT contracts, implementing the metadata, and a lot of the other standards that come with NFTs on Flow. So if you've already seen this part or know how to have a sort of intermediate experience in creating contracts on Flow, then I'll put a timestamp below so you can skip it. Now let's get into it. So with Flow contracts on, with NFT contracts on Flow, we have to adhere to a number of standards. Now standards are basically so that people across the Flow network can interact with your NFTs in a consistent and common way. For example, if I created my NFTs completely different from someone else, then it'd be super hard to interact with every NFT in a consistent way. So these standards really make sure that everyone can interact, buy, sell, use, view your NFTs in a pretty standard way. So let's get into the setup for the eventual contracts we're going to create. So getting, real question right here is, how do you find these standards? On GitHub, Flow has created a repository of, contracts with these standards. As you can see here, we're on the repository right now. Now we click on contracts. We can see a number of different standards here, including a non-fungible token standard, metadata view standard, and if you go into utility, a fungible token standard. So we're going to start by implementing the non-fungible token standard. We're going to copy and paste all these standards into the playground, and then I'll talk briefly about going sort of in depth into how these standards work. So now we're going to copy and paste in we're going to copy and paste in the fungible token standard next. Into the second account there. We go into contracts. Then we're going to copy and paste in the metadata view standard. Perfect. All right, so now let's go a little bit into depth into what these standards are, how they work, and what is even going on, right? Okay, so first we're going to start with our non-fungible token standard. This is the really essential standard for our non-fungible tokens. Like I said, this allows people to use and view and buy and sell your NFTs in a consistent manner. So starting with the non-fungible token standard, it is a interface, like I said, comes with the ability to basically see a total supply of how many NFTs are in existence. This is an event. An event basically occurs when someone interacts with your contract. A event will basically be sent out to everyone that's using the contract. For example, with this is a contract initialized event in which basically when you initialize the contract, everyone that is viewing it can see it. Now going over, we can see a withdrawal event, which basically was when someone can see when someone has withdrawn the NFT. Can see when someone has deposited the NFT. This is another event. Now moving over into sort of the resource itself. Resources are unique to Flow. They're basically these sort of, I would call them almost like houses. That's the best way I would think to call these sort of resources that can be moved around from account to account, to storage from storage, to basically interact with your NFTs. So as we see here with our interface iNFT, it comes with a unique identifier that allows you to see every NFT from a unique, have a unique identifier to each NFT, so there's no sort of overlap. This is an ability to see views, to get metadata views. Metadata basically on NFTs are things such as your title, your image, your description, the person who owns the NFT, things of that sort. Now going over into the iNFT, once again, we have this sort of ID, this unique identifier, so nothing really overlaps between any NFTs. Now going into our provider, this just removes the NFT from the resource and moves it to the caller. With Flow, there's this really unique thing called storage. Basically, with each account, there's a number of different storages. There's a public storage and a private storage where NFTs can be moved into. A lot of these sort of more basic Flow knowledge, I put videos down below that you can go check out. For this video, we'll be making it sort of more beginner intermediate level. So we're not going to go into so much depth about sort of the resource interface, what are these words? But I'll make sure to put videos below that you can sort of go over, what is a public storage, what is a private storage, and a little bit of a flow 0 to 100, so you can sort of understand more in depth about what is even a pub fund. But going more into the interface itself, this is sort of a withdrawal function that you can withdraw from the receiver or withdraw from the provider. Going more into the, right now we can see there's a collection public. Like I said, contracts have public and private storage. This is the public NFT storage. Basically, with each NFT, they'll go into your private storage, and then you'll put a basic, a public interface out there that people can interact with your NFT in your private storage. So this is basically an example of that. We have a deposit, we have get IDs, bar NFT, so you can basically check out the NFT, check out its metadata, and things of that sort. Now going into our collection, this is sort of like the overall collection of the NFTs that exist. So with this, you can see things such as like owned NFT. So I would be able to use that ID that I said earlier with this collection and then uniquely find that NFT. You can get IDs, you can see how many NFTs are in the collection already. And you can see, how many owned, basic things of that sort. And then lastly, you can create an empty NFT collection that basically just allows the creator to see, to basically create an empty NFT collection in their own account. So now moving over to our fungible token standard. This is a contract interface, just like the non-fungible token standard. With this, with NFTs, those are non-fungible tokens, which means that like pretty much every token has to have a unique identifier. With fungible tokens is a little different. Not every token needs to be unique. With tokens like Bitcoin and Ethereum, those are examples of fungible tokens that can be given out in a non-unique manner. With this as a example of interface for a fungible token, you can have a total supply, you can initiate tokens. These are sort of the events that I talked about earlier. Now moving over into our provider, same thing as NFTs, you have the ability to withdraw. Now moving on to our receiver, very similar to NFTs that we just saw, the ability to deposit. Balance is a new one. So basically how these fungible token standards work is you get a vault. So the standard will give you a vault where you can own these NFTs in your private collection. And this is an example of this right here. You see the total balance of a vault. You get a balance here, and you can basically see how many fungible tokens you have in that vault. And right here is an example: public resource with a vault with a number of the other interfaces that we just talked about. You can withdraw from this vault. You can deposit tokens into this vault. All come with these pre and post. So I'm going to talk a little about these pre and post here. This basically makes sure that, with all of these functions here, it makes sure that you're not violating anything. For example, here with withdrawing, it's making sure that you're not like withdrawing more than your balance. Obviously that wouldn't make sense. And then Also here with post, it's doing the same type of thing. It's just making sure that your balance is makes sense mathematically. And these sort of just make sure that the function works overall and nothing like really funny is going on. And then same thing, we're creating an empty vault for our fungible tokens. Now moving over into our third contract, here we will change these to OX2 and OX1. We're doing that basically because this OX2 is referring to this contract here, OX1 is referring to this contract here. Before it was done in sort of a file standard. With here, that's a little different. So now moving into our metadata views, we'll have an interface resolver where we'll get the views, resolve the view. We'll have a resolver collection where we'll get IDs from the metadata. Metadata, like I said earlier, is basically the ability to see, your title, your image, your description, all that good stuff. And then we see it right here, UID, UUID, external UI, collection ID, collection display, all that type of stuff. Basically, we'll go into this a little bit in more detail later, but we have an ID for the NFT, a unique identifier. Display is sort of, basically, okay, we have it down here, but this is sort of like the core data behind your NFT, an external URL, royalties, all pretty standard stuff. We'll go down and explain it a little bit more down here. You have a name, description, a thumbnail for your display. You can get the display. You can put a file in that represents the image of your NFT. You have an edition. Editions. You have a serial for your NFT, which basically is, like I said, that your UUID. Royalty. So basically, these are really popular NFTs. The original creator can get 5% of all sales, and then also all resales as well into the future. So it really creates that sort of really great incentive to continue with the project. Media, these are things like images and videos and anything you would like. A license, so these are things like if you wanted to allow anyone to use your NFTs for anything, that you can create a license onto it. And then NFT collections with these paths and collection paths. Like I said earlier, with Flow, you can have public, private paths, and basically put these collections into whatever you would like. And then this is the NFT collection display. So these are things such as, the socials behind the person or the company that's created NFTs, banner images, square images, just to represent the NFT collection as a whole. Rarity, these are things like, you could have traits on top of your NFT for games, for example. Like an NFT could have a rare helmet or a super rare armor, anything like that. That's basically what comes with these rarities. Same things with trait as well. And you can basically get all these things via these sort of public functions. Obviously, we won't be implementing sort of all of this, but we will be talking a little bit about more of all these things as we get into the rest of the video. Awesome. Now that we got that set up out of the way, let's dive into making the actual contract. Now, to be forewarned, before we start diving into the contract, this is going to be a super, super long contract with a lot of scripts, a lot of transactions. So we will be copying and pasting some, so this video doesn't turn into 4 or 5 hours. So just be warned about that. With the transactions and scripts, we're sort of just going to look over those as we have, I think, maybe 6 or 7 of transactions, 6 or 7 scripts, so a lot of stuff. And our contract, I have it here, has almost 9 pages. So it's a really, really long contract, but don't be worried. Every single line of code that is written for this contract, we will go through. So don't worry about it. So with that being said, let's dive into making the actual contract. So first, we are going to import our fungible token and non-fungible token contracts from our accounts 1 and 2. We're then going to create our basic contract called rent NFT. And now we are going to import just some basic events that we see here. um, as so. Actually, we'll input our events, and then I'll write out the rest. But yeah, so right now, as we can see here, we have a number of different events that we can sort of that anyone listening to the contract can see, such as NFT deployed, NFT listed, NFT removed from list, NFT rented, NFT returned to owner, and scroll finished. Before I explain what all these events mean, let me explain, I guess, exactly how this rent NFT works. So essentially, we will put an NFT into escrow. So basically, say I'm person one, or I'm Alex, and I'm going to give it to Josh. So I give Josh my NFT. In exchange for my NFT, he puts up a certain amount of flow. So he puts up a certain amount of flow, and if he doesn't return the NFT to me, then I receive the flow, and he gets to keep or if he doesn't, like if he fails to return the NFT to me, like says that essentially, oh, like I just want to keep it, whatever goes on, then I get the flow as collateral. So that's essentially how the NFT works. If I rent the NFT to him and he returns back to me, then I will receive some flow for that renting, and I give back that sort of collateral that he put up for the NFT. So that's essentially how the contract works as a whole. You're going to see that sort of theory happen or go on a lot in the contract. But anyways, going to our events, we have basically these are just, like I said, a lot of basic events from that theory that I just told you. NFT listed, NFT removed from list, return to owner, and escrow. So escrow is that sort of collateral put up and those NFT put out. So then we're going to move on to access. Contracts, var, NFT rents list. And this is just going to be a dictionary in which we are going to basically have a unique identifier and then be able to access the rent list from the unique identifier. And that's only going to be accessed within the contract itself rather than anything else. And then after that, we're going to have our rented NFT list. This is also going to be a dictionary in which we have a unique identifier and we get returned a NFT listed data. So it looks awesome. Oh, unique. I did not meant to put that. Sorry. You went 64. And now moving on, we're going to get listed NFTs. This is basically just going to allow us to see which NFTs are available. Are they currently listed for rent? As you can see here, which looks great. After that, we will create a public struct for the NFT listed data. So this is allow us to basically create metadata for the NFT listed. This we will just copy and paste over, and I'll explain in detail what's going on line by line. Public. So with our public struct here, we're going to be having a number of different inputs and variables attached to it, such as our list ID. So in addition to the UUID, we're going to have an ID for the list. And then we're also going to have a number of different things, such as price. So what is the price to rent the NFT? What's the collateral? So that's like I said, the money that will be given to the original owner if the NFT isn't returned. And then a deadline for when you have to give back that NFT, and then if it's already rented or not. So basically if it's available for people to rent. And then we just create an initialization for the contract here. And we just assign variables, or assign all of our initialized, or all of our variables up here with basically just inputs into this initialization function. So all very, I would say, relatively common stuff when it comes to creating a NFT contract. moving on, we're gonna have a uint64, where we're basically gonna create the next function, which is gonna allow us to essentially get the listed NFT individually via its unique identifier. So this is a very helpful function that we're going to use, relatively common or relatively often. That's going to allow us to get the individual NFT throughout the function. Sorry, let me do that really quickly. And then if we find that, the listed NFT that we're trying to get isn't available, then we're just going to panic. So we're going to say, hey, we couldn't find the NFT. What's going on? Let's panic, basically. It's going to abort the whole function and just give us an error. So that is the get listed NFT function. Moving on, we're now going to sort of, off the back of that, create a new function called get listed NFT data. So this is going to allow us to do very similar to what we did before, have a UUID that we're going to search up, and we're going to get the data from that listed NFT. And we'll just copy paste this over as well. Basically, it is just returning the listed data with all of the initialized, with all of the sort of data that we have here. So let me explain this a little bit better. So we get the listed NFT data, we're returning the NFT listed data, and we have this struct here that we just declared, and we're going in here and saying our list ID is our ID that from here, and then all of this data after this is using the get listed NFT function to get things such as NFT ID, UUID, price to rent, collateral to rent. And then we're returning it in this organized struct that anyone can see. So that is our get listed NFT data. Moving on, we're going to go into our list NFT. So this is going to allow us to list an NFT for anyone to use. We will also copy and paste this over as well. And sorry, just quickly looking through my notes. Okay, awesome. But yeah, so basically anything for any of these sort of inputs, we're just going to copy and paste over, and then we'll specifically write out, obviously you can see like it's very long, this contract. So I know it's already getting up there in time, so I don't want to make sure you guys aren't sitting here watching me create just putting in inputs. So we'll write out the specific sort of important data, and then, or sorry, the specific inputs of this function, and then anything like these inputs that are sort of repetitive, we'll just copy and paste over. But let me quickly write out the pre, and I will explain sort of what's going on, what inputs we're putting in to this, and how this pre is making sure that the function as a whole works. Get IDs. Link. 0. Side collection. Empty uncap that far. But basically with this pre, we're just making sure that that there wasn't an error from the user side, so that they're basically what they're saying is true. That they have this NFT, that they have it within their collection, and that they can rent it out to someone else. So that basically allows us to make sure that everything that's happening makes sense, that there really are no errors within the contract itself. And that we are all good on that front. Just writing out this last little part, and then we'll sort of explain it line by line. ID, incorrect ID, exclamation. Awesome. Okay, so let's take a look at what's going on with this function. So lots going on, to say the least. So this is an essential function. Like, we're listing the NFT, the rented NFT. We have a flow token, and we're inputting the capability. So these are a number of different, sort of essential capabilities, like the fungible token receiver, the owner cap, the type, basically just essential inputs that allow us to rent or list the NFT later on. And then moving on here, we have a pre. So this is going to make sure, like I said, to just see if the user themselves have the NFT inside the collection and are inputting the right ID. So just making sure everything is going on is right, and there are no errors that occur. So moving on, we will be creating the NFT rent list, and within that, we're going to create this UUID. So, like we said earlier, and then I'll be just copy and pasting this over as well. Destroy empty. And emit NFT listed. Here, list ID, and then we're with this function, essentially, we will be just emitting that, or we'll be emitting and saying, hey, like, if you're listening to this contract, we have just created an NFT, or we have just listed an NFT for rent. But I'm going to copy and paste this over, and then we'll explain what's going on sort of with these last two parts. Awesome. Okay, so here we have an empty constant, and then we're saying, or we have an empty let variable here, and we're saying rent NFT.NFT rent list NFT UID, and within that we're going to basically create a rent list. So we're saying, hey, here's the NFT, we're going to rent this, we're going to put it on the list of available rented NFTs, and this includes things such as flow token NFT owner pub cap, NFT owner cap, NFT ID, price of rent, collateral rent, deadline of rent, and NFT UID. So all just essential inputs for renting, or calling this rent list function. And then after we're calling that, we're putting it with inside the NFT.rentList NFT UID. So we're putting that inside that sort of dictionary. And then we're eventually emitting NFT listed, which basically says, hey, we just created, or we just listed this NFT, check it out. So moving on, we're going to create a pub resource rent list. As you may have seen, like, this is a pretty in-depth contract, which may be a little bit above anyone that may be beginner level, but make sure to continue. Like, the contract itself has a lot of great comments, so I'm going to make sure to put down below a number of different things that you can look at to sort of help you understand what's going on with this. Obviously, if we did this at sort of more of a beginner level, it would take much much longer to explain basic things like capabilities and receivers. So we're keeping it a little bit more higher level, but I will make sure that you guys will be able to get up to the level to understand this by inputting it, or below in the description, inputting a lot of different stuff that you guys can check out to understand the contracts better, or understand like the flow language in particular, and then understand the contracts as a whole better. So both should be really, really helpful. Awesome. But I will try to get through this relatively quickly. I don't really want this to go over an hour for you guys. I know that can be a little bit extreme sometimes. You know, when I'm watching videos, they like go to 2, 4, 5, 8 hours. I'm like, oh man, like tell me the essential stuff. But that's sort of how I'm trying to set up these tutorials for you guys. But for this, we're basically creating two capabilities. So we're accessing within the contract this entity owner public cap and an entity owner cap. So these are two things that allow us to basically input from the capabilities and access them within the contract themselves to see the flow token, entity owner cap, and the NFT owner cap itself. Moving on. We will just copy and paste the sort of rest of this contract, this resource, because it's sort of, I would say, relatively repetitive. Public let. So this, sorry, as you can see here, is it an NFT type? Nope, we have an error. Small little error here, my fault. Unexpected. Okay, so we didn't put a function here. My fault. Okay, should be good now. Awesome. Okay. Listed NFT. There's a small error there as well. Let me just make sure. See exactly what's going on here. Expected token. Okay. So this is a get listed NFT. We're expecting a token here for some reason. Exactly what's going on. So let's copy and paste it over from our final contract to make sure and just see listed NFT. Let's see exactly what's going on here. Okay, I see it. So what we're missing here is just this right there. That should make it all good. Okay, cool. Moving on. So for a public resource NFT or rent list, we are inputting a number of different variables such as NFT type, NFT ID, price to rent, collateral to rent, deadline to rent, and already rented. But basically all those variables, I wrote out some really good comments there. If you want to check out sort of the comments in more detail, then feel free to look at those within the GitHub repo that I listed below, which should help you sort of, if you want to go back, you can always go back. But the GitHub itself has a lot of really great comments that, obviously, like, I may be trying to make this relatively, I wouldn't say short, but like not super, super long. So just allowing you guys to basically do that, or go through the contract line by line yourself, and sort of understand some things that I may not have explained that greatly. That receiver. But basically, for what we're writing out right now, this is a public function for renting a listed NFT. Fungible token .vault. And will allow us to basically rent an NFT that has been listed on top of the or has been listed onto our contract. So then we're going here and we're going to basically look through and make sure that, like we did earlier, just make sure that everything's like good. There are no errors happening. That everything makes sense in the sense of collateral to rent, making sure that they have enough payment. Excuse me. That basically they have enough money to rent the NFT itself, making sure that the NFT isn't rented already, which we're writing out right now, and then making sure that the owner cap is able to borrow the NFT itself, that it's there. So all just checks to make sure that nothing's going wrong, that everything makes sense in the function, and that no one either maybe intentionally or unintentionally doing something they may not be allowed to. So basically, going back line by line, we have payment to rent and collateral.balance. So we're taking the price to rent and the collateral to rent, and we're making sure that they have enough money to rent the NFT. And then self to already rented is equal to false, which means we're looking and saying, hey, is the NFT already rented or not? And then we're doing NFT owner.borrow, and we're saying, can we even find this NFT within our rented list? Is it available? Can people rent it? So those are sort of our pre's right there. Moving on, we will be continue to sort of go on and read through a lot of this code. We may be having to sort of copy and paste over some more stuff. I'm looking through, we have a lot of pages. So making sure, I know it's probably already getting to like an hour, so I want to make sure that you guys aren't here for too long. So I will try to speed through some of these parts that are sort of easy to understand. Self.flow token, to public app, .borrow, .deposit from payments. Right. Awesome. Okay, so for here, we're creating another variable. We're depositing into the NFT owner wallet the rent value. So basically, all the money that's being rented in, we're depositing it into the owner's our wallet already, and then we're creating a collateral within the contract called a collateral value, and that's going to be to rent the collateral itself. And then after that, we are sending it off to the NFT owner cap. So basically, after we sort of deposit all that money into different people's wallets, we're going to move the NFT into the renter's wallet. And then UID, nt.uuid. So we're going to send this out to the renter's wallet. All of these lines have a lot better detail in the, or have a lot of comments in the GitHub, so make sure to take a look at that if I'm going a little bit too fast. Pause it. Token NFT. So here, we're creating this variable called NFT. We are borrowing the NFT from the original wallet, and then we're creating, and then we're depositing it into the renter's wallet. And then we're declaring self.rented, already rented is equal to true. After that, we're going to basically, let me just restart. Okay, that's where we are right now. We will basically be copy and pasting this over. We'll copy and paste the rest over because I know we're already at almost 30 minutes. So let's copy and paste this last part over and I'll explain it. But essentially we're creating the escrow. So we're saying we just gave all this money out to the respective parties. We put the NFT into the renter's wallet, and now we're creating an escrow in which if the renter doesn't return the NFT, then the money will automatically be given to the original holder for their NFT. And then they're going to emit an NFT rented. We're also going to get the capability and deposit the necessary tokens into the escrow for that collateral. And then after that, we're going to have the rented NFT list, NFT UID, and we're going to insert the NFT listed data into, or we're going to basically create an NFT listed data and put it into the rented NFT dictionary to allow us to basically recall at later times. After that, we're going to have a rent NFT rent list.remove. So we're basically going to go into the rent list and remove it from the rent list and say, hey, we just created we just rented out this NFT. We don't need to rent it out anymore. So don't really worry about it, essentially. Moving on, we will be creating the remove from list and destroy function. This is a super important function. Sorry, just checking out some of our last parts. I think we're going to sort of go through a lot of this stuff in more detail, and then we're going to sort of copy and paste the last part and quickly go through the NFT. Yeah, I think that's the best way to sort of structure this. Yeah, okay, awesome. So now moving on to our next big function. This is a remove of listing and destroy function. So this is going to allow us to get the owner cap, get the capability, and then non-fungible token dot provider, non-fungible token dot collection public. Boom. Borrow this. Borrow the NFT. So this function in itself basically allows us to remove the listing from the rent list and then destroy it. So super important function that allows us to really just basically, like I said, remove it and then destroy the comp itself, or destroy the listing, and make sure that no one else can list it and no errors occur from that end. So the NTID. So let me write out this really quickly. T rent lists dot remove key NTUUID. But basically, with this pre, we're going to make sure that the user has access to this NFT, and then we're going to borrow it from the NFT owner cap via its unique identifier, and then we're going to get that UUID, and we're going to remove it from the rent NFT, and then we're basically going to destroy the rent list. So we're going to say, hey, we just rented out this NFT, destroy the listing so that no one else can basically re-rent it. This is sort of redundant. I mean, obviously we have a lot of, checks to make sure this doesn't happen. But just for the front end, we want to make sure that this is available and that people can see it, or that we can update the front end with available NFTs, and that there aren't a lot of NFTs that aren't available. Moving on, we're going to create an initialization function at the end here. Copy paste this over. So basically, going line by line with this, we're gonna have a flow NFT. Sorry, a flow NFT public cap, NFT owner cap, NFT ID, price to rent, collateral rent, deadline of rent, and NFT UID. So this basically just allows us to create this NFT listing and make it really, really simple for people to sort of follow. Now moving on, we're going to create a quick interface. It's going to be called Scrow Public Collection with a number of different functions, such as deposit, with a return of a resource called Scrow, public function get open, Scrow's IDs with a uint 64, and a public function for getting the ended Scrow IDs with a uint 64 as well. And then a public function get ended Scrow data, the Scrow ID, uint64, the Scrow data. And then we're also going to create the last one called Scrow data as well. Awesome. Okay. Moving on. Next. Okay, just got 2 more pages left. We're then after this, we're going to create our public resource called Scrow Collection, and this is going to be a Scrow public collection. Scrow's list, and this is going to be a 2 different dictionaries that we can access at any time, in which we can insert the unique identifier for the scroll and see if it's available or not. And then in addition to that, we're also going to create this next dictionary, which is going to be scroll data. So this is going to allow us to basically look through and see if the scroll is available. Scroll. Next, we're going to create this deposit function. Oh my God, guys. Deposit function, which allows us to basically just look through, see if or deposit a scroll to the scroll list. So this allows us to basically create a new scroll and then insert it into the scroll list dictionary that we just described before. .uid. Then we're going to create a scroll list ID. No, my bad. Scroll. Just inserting that sort of function we just had before. And then we're going to destroy the old scroll. Now moving on. I don't want to copy and paste that much over, but I know we're getting up to almost an hour here. I don't want to hold you guys for that long. Deposit. T to owner. Okay. We'll do this next little part. We'll write out line by line for you guys, and then we're just going to copy and paste the last part and go through the transactions and scripts themselves. So it should be another, I guess I would say, around 30 minutes. If you guys don't want to sit here watching me write this out and explaining it, then feel free to go check out the GitHub below, which has a lot of the data, or has a lot of the lines written out with a lot of great comments as well. So now we're getting the get open scroll IDs. So we're gonna check and make sure and see, what's going on, which scrolls are open, and then we're also creating another function underneath it, in which we're going to basically see and say, we have the open scrolls IDs. We also want the ended scrolls IDs as well. So that is what those two functions do. Both really essential functions to allow us to get more data on exactly what is working, or what scrolls are available for people, or what scrolls are currently up and which ones are not. So next, we're moving on, and we're creating a function in which we can see the finished scrolls. And just getting the sort of scroll data and seeing via the unique identifier, seeing basically which are available, which are not. So that completes that. Moving on, we're going to need our public function of get scroll data. So we just got our ended scroll data. This is going to allow us to see the scroll data for an open scroll instead. So we're first going to have this sort of if statement that says, hey, if this isn't available, then make sure to, if this isn't available, then make sure, that if the scroll isn't available, then let's make sure that we can allow people to not allow people to check this sort of data out. If it is available, then let's make sure that we can sort of return this data as necessary to the viewer for NFT. Let's go. And then we're returning the scroll data to the user with things such as NFT ID, scroll, ref that NFT ID, and then NFT UUID. We can copy paste this over. It's just repetitive, I would say. Cool. So yeah, basically with this function, we're getting this open scroll data. We're finding it in the list that we just created, and then accessing and then returning it to the user. If we find that the scroll isn't available, then we're just going to return no. So pretty standard function there. Moving on, we're going to create our next function, which will be public function return NFT to owner. It's going to have our scroll ID, a uint64, NFT rented, non-fungible token, .nft, NFT renter, low token pubcap to the capability of fungible token receiver. So that pretty much concludes it for this input. So this function, I don't know if I've described it yet, but basically returns the NFT to the owner and the collateral to the renter. So it's a key function within this contract. And we're basically inserting a number of different inputs, having a pre like our others to basically just make sure that everything is good. Scroll does not exist. And then a self.getScroll data. The scroll ID and a scroll ID again. The NTUUID is equal to NTRented.UUID with not same NFT. So that concludes it for our pre. We're going to move on to our scroll itself, which we're going to self.scrolls list.remove key scroll ID. Awesome. Turn collateral to empty render. So this is going to basically return our collateral to the NFT holder, or sorry, to the renter itself. Enter renter public flow cap. And then within that, we're going to basically return that with the pub cap. And then have this scroll dot return NFT to owner. So this is going to allow us to then return the original NFT to the owner itself. Let scroll data is equal to scroll data. So this is going to allow us to get the scroll data. We're going to copy and paste this over. These are just the inputs. Date of end. Pretty much everything makes sense here. I would say the only thing that may be a little confusing is probably date of end. This basically just allows us to get the timestamp of the current time and say, hey, we just returned the NFT. This is the timestamp. Make sure to put it in. And then now that we have created that, we're going to emit a NFT returned to owner, the scroll ID of scroll ID, and then NFT UUID of scroll.NFT UID. And they're basically just going to destroy the scroll and self.finished scrolls of scroll ID is equal to scroll data. So that concludes it for that function. We're basically just going to be emitting and saying, hey, we just returned the scroll. We're going to destroy it, and then we're going to put the finished scroll into there. So now, moving on, public function, finish scroll, the scroll ID of uint64. This is going to be the finish scroll. So we just create a number of different functions to sort of identify what happens when we do access this scroll. This is going to basically allow us to finish the scroll and make sure that we can, like, this function itself just allows us to finish a scroll without returning the NFT, and it sends the collateral to the NFT owner instead. So we just created that function before that allows us to basically return the collateral and return the NFT to the holder. This function in itself allows us to basically say, hey, the NFT hasn't really been returned yet, like something's gone wrong. The renter decided to keep it instead of returning it. And so this function allows us to basically return the collateral to the holder, say, hey, sorry, like something went wrong. Here's the collateral that they put up. Even though you don't have your NFT, you do have a lot of tokens in return. So that pre there allowed us to basically make sure that the scroll existed, and then also make sure that no one's trying to abuse it. So that ensures things like, you know, I would say collateral to NFT owner. That ensures things like that makes sure that, like, no one is trying to receive the collateral before it's actually due, that no one's sort of abusing the function as a whole, and that everything's sort of going okay. Scroll. Finished scrolls with a scroll ID. Scroll data. Emit. Scroll finished. Scroll ID. Scroll ID. And after this, you sort of create initializing, just writing this out really quickly, and then we will explain it to y'all line by line. It's our sort of last part, and then we're just gonna briefly go through the transactions and scripts. So I know it's already almost an hour plus. Don't want you guys sitting here for almost 2 hours with me. But okay, let's go through this finish scroll. So like I said, this finish scroll allows us to basically return the collateral if something's gone wrong. So we're getting these pre's to make sure that nothing's being abused. We then go to the scroll list, we remove, then we send collateral to the NFT owner. We get the scroll data, which I'm going to copy over. Right here. So we're just accessing this and making sure that people can see, like, hey, the scroll didn't go right. We're creating that data and we're putting it into the finished scrolls, and then we're emitting finished scrolls. So that pretty much does it for all of that. We're then just going to basically copy and paste the rest of this part, and I will explain it to you guys line by line. We'll copy and paste the whole contract, probably easier. Unexpected token. Before I do this, let me just make sure that so let me fix error before I copy and paste the whole contract so you guys aren't confused. Where is this? Oh, here. Oh, that's why. This is commented out. So, you don't need that. There are a couple errors. It's my bad. Method identifier. But yeah, just a couple of errors. I mean, the GitHub below has all the correct sort of data, but or has all the correct has all the correct sort of lines. Maybe a little error, one or here or there, but go look at the GitHub if you can't figure that out. But now moving on, we just sort of explained all the finished scroll. We then create the struct for the scroll data itself. We initialize it with NFT ID, collateral, finish, data of end. We then create the scroll resource. This is where we store the rent information, such as NFT pub cap, NFT flow token cap. Then we can get the collateral, return collateral to NFT renter, return NFT to owner, and send collateral to the NFT owner. So this basically allows us to call all these sort of functions that we've been creating throughout it. Then we have NFT UID, we have collateral, just basic structs. We have an admin down here as well. This allows us to rent the listed NFT, allows us to destroy listing that may be on there. And then we also initialize this at the very, very end, in which we just create all of these sort of accounts, link the accounts, put the admin as the creator, and then admit that the NFT was deployed. So that's pretty much does it for the renting NFT. It may have been a little bit quick at the end. Feel free to go through the GitHub below to sort of understand a lot of this stuff in a little bit more detail. So now moving on, we have a ton of scripts and transactions. We'll start with transactions. Let me just open all of these and then we'll go through them. So starting off with our finished scroll, this just basically calls the finished scroll. We borrow it from the admin view and then finish the scroll with the ID. So that's nothing too crazy. This is the list NFT to rent. This is a little bit more in depth. We basically prepare the auth account. We sign it, we get the capabilities, we unlink it, and then we link it. So we're basically just going through, we're saying we're going to borrow this, and we're going to input all these sort of variables to rent the NFT itself. Now moving on to remove NFT from list. This is going to allow us to borrow the NFT, get the owner cap, and then destroy the listing. So we're basically just removing it from the list. Moving on, rent listed NFT. This is admin.borrow. We're going to get the capability, get another capability, and then get the listed NFT data, get the collateral, rent price, and payment value, vault ref, payment to rent, collateral, and then we're basically just going to rent the NFT based on all these inputs, get the necessary price and collateral, and just insert it via that. Now move on to return NFT to owner. This borrows the scroll collection, gets the ID, borrows the signer cap, withdraws it, NFT renter flow token pub cap, and then returns NFT to owner. So just calling the functions that we've seen before. Move over scripts. I know this may be really, really fast for you guys, so definitely make sure to check out all of the necessary scripts and transactions below in the GitHub yourself. I know this may be a little quick, but we will talk about these sort of functions a little bit in more detail in part 2, where we implement them into our React.js website. So here we're getting the end to scroll data, just calling the capability and then calling the function. Same thing here, ending scroll IDs, we're just calling the capability and then calling the function. Get listed NFT data. We're just going to get the listed NFT data by calling the function itself. Get listed NFTs, very similar, just going to call the contract and then call the function. Get open scroll data. This is similar to the one we just saw. We're going to get the capability from the account and then call the scroll data. Get open scroll IDs, same thing. Get the capability, call the function. Get rented NFT list data. This is going to be getting the rented NFT list ID and then getting that. And then keys, this is just going to get all the keys from the rented NFT list. And then returning it in an array. So that pretty much does it for this part. I know it was a little bit quick at the end. We will be explaining a lot of the scripts and transactions in a little bit more detail in the next part as we implement them in a React.js website. So make sure to come back for that. Thanks for watching. And if you have any comments, make sure to put those below and I will try to address them.